Hello, wonderful probability and statistics students. So today is BoxPlots, and I'm out in my living room because it's extremely cold in my office. It is the coldest room in our house. All right. So you have all this wonderful stuff: range, 5-number summary, BoxPlots, interpreting the BoxPlots, shapes, worked examples, GeoGebra BoxPlots, which some of you have used. So if you want help with that, please let me know. You don't have to work through that alone. It's just not a majority, so I just kind of say it's optional because there's other options online now that you can use. Okay. So let's go take a look at the quiz. And I hope these are helpful. So if they're not helpful, let me know. Great job, those of you who've completed it, but there's about 20 more who haven't. Box plots or box and whisker plots are some of the same names. It's just another way of representing data. Now here we want numerical data, okay? So that's really important. Excuse me. So let's scroll down. Remember, you have your textbook, you have a solutions manual, you have all sorts of stuff. So some vocabulary. What is the range of the data set? When students first look at this, sometimes they think to themselves, I know, well, it's from 1997 up to 2009. That's a range of 12 years, right? 12 years, let's see that right? Yeah, because it goes up to the 2000s. Yeah, 12 years. No, that's not correct. Okay, so don't do that. Your range of your data, it has to do with where the data is actually at. So you need to look, okay, there are 3 dots above 1998. So 1998 is the lowest value in our data set. That's just the lowest on our scale, on our x-axis, on our representation. We could have stopped it at 1998, but sometimes it's nicer to have a blank reference or a couple units to the left or to the right. Okay, same thing over here. There's no dots over 2009, so the max year is 2008. So now what is the range between those? Well, you can see it's 10 years. Mathematically, whatever. What you do is you do 2008 minus 1998, 0, carry the 1, 9, carry the 1, 1, 10. So that'll always work. You can take your maximum value, your minimum value, subtract them, and that will give you your range or the distance between your lowest and highest values. Okay, let's see if we are correct. 10, boom, 10, nice. Okay, moving on to the next value, to the next one, up. Okay, question 2. The box plot summarizes the heights and feet of a sample of 500 coast redwoods. Bill thinks that there are more trees taller than 321 feet than shorter than 288 feet. Is Bill correct? Okay, so this has to do with how a box plot splits up your data, and that's kind of important to know. And what do you see? Let's see if we just zoom in and look at this box plot. If I were to describe it, it looks like there's a section here, and we call this a whisker. That represents the minimum, wherever it's over on your scale. Okay, over here, another whisker. That represents the maximum, so 372, 3, 4, 5, 6, 7, 8, 9, 10. Wow, that looks like 379. I don't know. Okay, and then this right here represents what? Is that the mean? Is that the median? What is the middle part of your data? And so that should be your median. It's not quite the same as a mean, which is the average. This median value is the middle data point, the very middle data point, or if you have an even data set, your 2 middle numbers added together and divided by 2, the middle, okay? And then these right here, the end of the box is your Q1 or quartile 1, quartile, fourths. It's really important. I know I'm kind of being silly when I'm emphasizing this stuff, but that's the whole purpose of a box plot, is it's going to kind of give you a quick, what we call 5-number summary. It's going to tell you the range, max and min. It's going to tell you the middle of your data, and it's going to give you, that box is the middle 50%, because because it's chunked in a quarter, one whisker, quarter of the lower half of the box, quarter upper half of the box. Altogether, the box is 50% of your data, the middle 50%, or 2/4, and then Q4, which is the top half of your data. So that's how we think about it. That's how we read it. The middle 50% is here. So now we got to go do some thinking. Okay. Bill thinks there are more trees taller than 321 feet. So where's 321? Okay, right here. So boop, boop, that's a fourth. Here's about 321, I would guess, right? 16, 17, 18, 19, 20, 21. So that's the end of our box. So a fourth of the data. Then shorter than 288 feet. Okay, 84, 85, 86, 87, 88. No. So Bill isn't correct, just from what I described. Because look, here's 288. So here's shorter. The value's less than 288. It's the entire whisker. So that's a fourth of your data points. Over here, here's 321. It's the entire whisker. So it's a fourth of your data points. So no, Bill is incorrect. Even though it may be the whisker looks longer, that's not really mattering. That doesn't really matter. It is showing you where the range, like how far away the maximum is. If this whisker is longer, it's showing that the maximum values are either more spread out, like they're further away from the middle 50%, right? And then the lower data is closer together. That's kind of all it's saying in the range, in the values, but there's still a fourth of the data, a fourth of the data, a fourth of the data, a fourth of the data. Okay. Which 5-number summary represents this box plot? Woohoo! So we have a min, we have a max, we have our median, we have Q1, and we have Q3. So let me kind of draw that so that you can have a better idea of what's going on here. The 5-number summary includes the minimum, so our smallest value, our maximum, our highest value. It includes our middle or the median, that's an A, sorry. And then we have what we call quartiles. And it's exactly how you would think about it. Quartile 1, quartile 2, quartile 3, right? This is our first quartile, second quartile, third quartile, fourth quartile, but the marks up to here, Q1 and Q3, are special. Let me change colors. Q1 will be the middle of the lower half of the data, and Q3 will be the middle of the upper half of the data. We'll go over how that works later, but that's just so you start to see where these numbers are coming from. And that's our 5-number summary. The Q1 and the Q3, you can think of it as useful because it captures the lower bound of our and the upper bound of our 50% of our data, the middle 50%. In probability and statistics, we really do care about measures of center or where most of our data is. It's going to help us make conclusions, or it's going to help us ask more important questions depending on what it represents. Okay, so hopefully this colorful visual kind of helps, but the minimum is 3, the Q1 is 8, the median or Q2 is 12. They're the same. Synonyms, Q2, quartile 2, and the median are the same. Q3 is 14, and the max is 20. So your 5-number summary should be 3, 8, 12, 14, and 20. 3, 8, 12, 14, and 20. Okay? I'm so sorry. I'm really ready for this to be over. Okay. Go back. Question 4. Question variation 1. The box plot summarizes the heights and feet of a sample of 500 coast redwoods. Cool. Approximately how many of the coast redwoods are taller than 288 feet? Approximately how many are taller than 288 feet, right? Because we don't really know much besides what our box plot is telling us. Well, here's 288. We already saw this box plot earlier. 288, 1/4 or 25% of the data, 1/4 or 25% of the data, 1/4 or 25% of the data. So you can see that above here, whoosh, there's 3 quartiles or 3/4 or 75% of our data is represented in those 3 halves. So larger, taller than 288. So now we can use some number sense and say, oh, okay, that means 75% of 500 is going to be approximately how many are taller than 288. Now, we say approximately because sometimes the mean and median, when you find Q1 and Q2, you include it or exclude it. And we'll talk about that when we actually deal with finding it ourselves. Right now, you're just being asked to read a box plot, not to find these values. So you will be asked to do that soon, and it's okay. You can do it. It's just adding, subtracting, counting, arranging in numerical order, all skills that you absolutely have. It just might take some time. 75% of 500, this is how I do it. 50% is 250, and then 50% of 250 is 125. So 250 plus 125 should be 375. So that's what I did in my mind. Let's see if we're right. You can use a calculator, but I was just breaking it down into friendly numbers. If just thinking about how percents work. So I halved it, and then I halved it again. So that'd be 50% plus 25%, which would be 250 plus 125 is 375. Boom. It's important to get that number sense, to play with numbers in your mind, just because you're going to have them all around you when you go shopping, when you fill up your car, when you make decisions. So keep the number sense fluid, right? Whenever you have opportunity to add, subtract, or think about numbers, think about, does it make sense, your final answer, and how you got to that final answer. The Giants, woohoo, shows the number of runs. I'm from Northern California, so we were Giants fans. I'm not really a Giants fan, but we were Giants fans instead of the Oakland A's. So those were the two teams we kind of either had, the San Francisco Giants or the Oakland A's. But anyway, okay, that the San Francisco Giants scored per game in a 162 game regular season in 2010. I have no idea if this is true. So it shows the number of runs. In approximately how many games did the Giants score 2 or fewer runs? Again, just getting used to reading a box plot. Well, here's the 2. 2 or fewer is down here. Notice it's just the whisker. So it's just one quartile of our data, 1/4 of our data. So a fourth of this. So you can just basically divide that by 4. Approximately how many games? So 16 divided by 4 is 4, so 40. And then 2 divided by 4 is a half, so 40.5. But I would say 41 games, because they're just saying approximately how many games. So that keyword makes me want to say 41. Well, let's see what they say. 40. Well, I would round up. They rounded down. Really doesn't matter. It's a multiple choice quiz. You could say approximately 40 games. Most people like nice whole numbers, 40s, 45, 50, right? Then 41. We always say, like, what time is it? Oh, it's almost 2. We don't say it's almost 2:02. We can just say it's almost 2 p.m. All right, you guys, I hope this helps you. This one was kind of quick, but that was the basic skills for a box plot. You can do it. You're always welcome to wait for these videos or try it. To ask for a retake. Remember, you have your book. Your book has the solution manuals. You just need to go match up your question with the solution, and you can see how they solve it. So I like any tools that will help you be successful. So thanks for watching.